So, hi everybody. I'd like to introduce our next speaker, Lily Campey, and her beautiful assistant, David. So, they're going to be sharing some robots. It's going to be great. David's from Afro Labs, that is one of the long-time sponsors of PyCon ZA, and that's fantastic. We're very, very grateful for the continued support. And yeah, he's been doing a lot of work around teaching kids, as many of you already know. So yeah, thank you, Campy Clan.
Thank you. Cool. Yes. So thank you for stopping Lily's heart there briefly. I'll let it start again, and I'll bridge to that part, and hopefully I don't repeat myself later, which is to say that PyCon is a really, really amazing place. PyCon is the reason that I do kids coding clubs, because 12 years ago at PyCon ZA 2012, which you may recall was the one at the pavilion at the waterfront, different space, there was an 11-year-old boy, so Lily's an 11-year-old girl, standing at the back of the conference venue. And I went to him and I said to him, well, wow, what are you doing here? And he said, well, no one can teach me about Python, and my dad managed to get me a free ticket, so I'm here to figure out how I can learn more about Python because they can't teach me at school. And so that's really the start of the journey. And now that Lily is 11, and that's 12 years ago, it just gave me such a moment for reflection that, like, wow, there is so much that I'm going to catch you up on very briefly that's happening now that's so different over the last 12 years. And the most different part is and robotics for all. So that's the topic of my talk. My name is David Campey, as Sheena had said. Most of my time now is spent in our not-for-profit, which is Coder Level Up. Coder Level Up is a coding community building not-for-profit started by Afro Labs, who we're really grateful sponsor this conference, are able to sponsor this conference. And I still spend about 20% of my time at Afro Labs, but the rest of it is Coder Level Up. Most of that is focused on Code Club, which are free coding clubs for young people. And that work is made possible from funding from the Raspberry Pi Foundation, which in turn comes from the Ezra Charitable Trust. And as I'll show you, there's a giant pyramid of shoulders that everybody is standing on to make stuff happen. So, and robotics for all. Today, I'm going to take you through the current context in South Africa and coding and robotics. Then we're going to have a quick look at creative learning and how we design an environment for that. And then probably what you came here for, the challenge, robots. They represent a very high ceiling, but with that comes some fantastic things. And then we're going to do a code along. So if you've got phones, I'm going to ask them to come out. If you've got laptops, bring those out at that point. We're going to do a quick bit of coding because it's the end of the conference and we're tired. So I can get the brains on and get the fingers on it. You can try to speed run it if you like. Maybe we just sow one or two seeds. Like the real goal here is to get us actually playing with the stuff, experientially learning so that we can connect our joy to it. And then I will invite everybody to contribute because that seems to be more than any PyCon I've been at before. A theme of this PyCon is let's contribute. Let's actually start giving. Maybe it's because my radar's on for contributing, but I've seen it really coming out this PyCon. So South Africa, coding and robotics. So this series of pictures takes us from struggle through imprisonment, through freedom, and then coming into unity, and then looking at how we take the future. It's a beautiful series of hand sketches by the president of South Africa, the former president of South Africa, Nelson Mandela. And I think for me, it represents the journey, that cycle, that hero's journey that we keep going on, and that today we get to look at and how are we doing stuff. And the big challenge in front of us right now that's super exciting is that our education system has now gazetted coding and robotics. We're one of the only countries in the world to have and robotics in the curriculum. Lots of people have coding curricula. But the and robotics page, part of it, is really interesting. And especially because our curriculum has come around, was developed in this 4IR period when we thought about how are we going to do and robotics. From next year, all schools for foundation phase, so grade R, 1, 2, 3, are going to be doing coding and robotics in class. Well, the good news is that like there are considerate people who've designed it, and everything in there can be done unplugged. So when you're dealing with grade 1s, 2s, and 3s, and you're doing robotics, some of the things you're doing is building a robot out of cardboard and putting eyes on it and saying, what would the sensors do? And controlling your friend as a robot, and how is it going to go? So that's kind of the easy bit, and then we're going to get to intermediate phase and then to senior phase. And we are going to be part of what that looks like because it's being co-imagined all the time. On Saturday, there's a hackathon happening in Delft where educators are getting exposed to how to help children make smart homes for the first time. All that stuff is happening. There's been a series of hackathons led by the Western Cape Education Department. It's super exciting. It's all coming soon. And it's a lot, right? So this comes from the curriculum document for all three of the curricula are based on this very complicated picture, computational thinking, logical and critical design thinking, building into problem solving, how it all fits together. As teachers, you need to have these pedagogical things rattling around in your head so you can know what those missing links are, where we need to reinforce. And then here we're looking at grade 7, grade 8, and grade 9, a map of what the curriculum is taking you through. You see lots of electronic bits and stuff, but there's a lot to digest. And the interesting part about that is like how to get into that was the question I was stuck with 12 years ago. When I was like, there's a boy, he wants to learn Python. I saw in Alex's talk earlier, the first time he popped up that slide, and actually, the first time he popped up the slide with Guido, it was like how to learn Python in 10 years. Was the subtext. I don't know if that was the AI's summary of the talk, but everyone's like 24 hours, 30 days, whatever. How to learn Python in 10 years? Like there's a problem. It's a repetitive problem. And so 12 years ago we started. Today we have 150 clubs here. Annalisa's at the back. She's our Western Cape Community Clubs growth manager and is helping to spread the fire into the Eastern Cape, where we've just started 2 new clubs. She's waving from the back. KZN, we have 200 clubs with our partners in Keep a Child Alive. And these are clubs that are extramural clubs. And the best part about that is some of us may have seen Moana. Most of us have the idea of a trireme with those supporting things on the side. Code clubs are like that. They can go under the water, they can come up. The middle boat stays afloat. So an extramural club, extracurricular places where we can experiment and grow. That's why I started there, because I didn't think I'd be able to get something into Sam's computer classroom. But I knew that I'd be able to start a club. So this is the place where we can do it. And currently, it's kind of mind-boggling to actually type that number on the slide, but thousands of young people every week are taking part in code clubs in South Africa. There are these clubs. When I put my hand up, I didn't start Code Club. I started a coding club. We joined Coder Dojo. Coder Dojo became part of the Raspberry Pi Foundation. The Raspberry Pi Foundation also adopted Code Club. And that means that the Code Club is now a global community of clubs where young people and educators are getting together to actually help. That global community is about 15,000 clubs strong. That means we get to share lots of stuff. That's very much what we need to do, and it's how we can remove duplication. One open source maintainer of one PLC library can be used all the way around the world, right? Someone who decides to make a pathway for how to get into microbit can be used all around the world. And if that comes from Nepal, some great people out in Nepal doing some interesting work, sharing how to do servers for managing kids' information. And then someone else from somewhere else is coming up with a coding resource for unplugged coding, which came from Malawi. Now we got Malawi Code Club on a stick sitting in Ngele out in Tombo village outside Alice, allowing them without internet to run a code club. And that is really the ethos of this whole open source thing that we're getting together to try to do. So, creative learning. How do we design this environment for creative learning? I've spoken to a few people over the last few days. Things that we find here are described as the 4 Ps of creative learning. This comes out of 4 Ps, 4 Cs. It's a guidebook coming out of the MIT Learning Creative Learning body of work. There's a lifelong kindergarten lab at MIT, which specializes in how we can keep this playful learning going forever. And the 4 Ps are, I don't know the order they're behind me, but we need passion. So we need to find something we care about, whether that's soccer, fairies, or unicorns. If I make a project that I care about, I'm going to put more of my subconscious into it, more of my emotional investment. I'm going to learn more. I need peers. I need to show someone. Coding on your own is okay, but You were saying earlier that when you put your speedrun online, you want to go and show someone and tell them what they did, or you want to help someone else along. That makes creative learning work. And then we want to do it playfully in an area with psychological safety, as well as fast feedback and those attributes that make that happen. And last but not least, we need something like a project. We don't want to just have like an endless progression. We want to feel like I finished something, I designed it, I started it, I finished it. So those are the 4 P's of creative learning. And then we want to create these environments. I am unfortunately going to move quite quickly today, faster than I'd like to. But this room here is a good room. It has wide walls, so it's got space for all sorts of different people to be in it. It's got a low floor when you come in. The lady who's coming in now, I'm not calling you out for coming late. I'm saying that she could be in a wheelchair and still get through that door because it's flat. So we don't have a big step to get into the room. And sometimes the challenge is our creative learning environments have a step to get in. And it's not like chemical titration. It's not like once you're in, you stay in. Once you're into that code base and you get out, then it's like, oh, am I going to go back in and do that again? I can't remember it, and you leave it. So the DevX stuff that was spoken about yesterday morning is really about how do we improve this user experience for development and really just get ourselves easier to get back to that creative space for grown-ups and for kids. So the stuff we learn for kids is great. And Jeremy pointed out that when Lily showed him Octo Studio, he said, this is the best user interface ever. It didn't give me a blank IDE. It said, what do you want to add first, a sprite or a background? You know, that's even easier. It's like, oh my gosh, that's what I wanted. I didn't want to be presented with a thing and a choice. It was like, which would you, sprite, I choose that, and now I'm going. So that's a great developer experience. You know, seeing what projects you had before and being able to reopen them is great. So we want a low floor to get in, but then we also want a high ceiling. Many of us may have experienced something where it's easy to get in, but you can't do much. Whether it's a toy, educational toy you've used, or a platform, which really just hasn't been designed with that expert level in mind. You can't really get anywhere. So we want a high ceiling, and then this slide comes from a interesting presentation that says then we also need tall ladders to get to those ceilings. So those are the concepts when designing creative learning, and that really is what we try to put together in the ingredients of a code club, which is a nice incubator to also think about how you might take this to work. So volunteers, like the people in the room, teachers, librarians, a venue, schools, libraries, community centers, projects, things to actually work on, and then children make up a code club. And once we get there, if you've seen some of my previous talks, you'll understand that this idea of the loop of joy is critical to me. That we need to have the struggle, that hero's journey. We need to leave home, we need to get lost, and then we need to come back. And what happens if I got an idea, I want to do something, and I struggle, and then I see it working, I'm going to have another idea, right? And that's what we want to do. We don't want to have an idea. How many people here have watched a video of a robot dog on YouTube? You've seen a robot, right? So you've got an idea, and then you thought, I want to do something. How many of you have made a robot dog do anything? Right. So we've got an unclosed loop of joy. If you were to arrive at a place and they had a robot dog and you moved it, you'd be like, oh, I've closed my loop of joy. That's quite fun, right? So those loops we open, and then how do we close them? It's like, I could check out that library and do a thing. How am I going to get it round there? So the goal with all of it is to help us design an experience that has these loops of joy that can be closed. So, how are we doing on time? This is my time check.
Sorry, I'll tell you now. 20 minutes. Okay.
Pardon? Okay, we're half there. Okay, so robots. Like, what are we actually going to do with robots? What do robots even mean? We covered a bit of this in the preamble. I think the thing for me that's most interesting about robots is they can be really remarkable. Robots are hard, right? Most of us haven't done much robots because they're hard to do. But when you pull them off, they're amazing, and people can kind of want to do them. So I'm going to cover a couple of remarkable robots. I'm going to start with a slide from Contact. Has anyone in the room read Contact or watched the movie? Okay, a small smattering. So Contact is this movie that's kind of like what we've got at the moment. We received a signal from aliens, from deep space. And it came with instructions on how to build a robot. but the signal was coming from the Vega system, so no one country could receive the whole signal. So the countries had to work together to make it. And it was such an ambitious project that all of the countries, all of us had to start collaborating to be able to do this thing. And so I thought it was pretty appropriate to add a last minute slide, because Carl Sagan wrote this book where he received code, engaged in a global challenge, and then united humanity. And then I saw, oh my gosh, look at that, Sorrel had Meerkat, right? Robots are going gazing into space. It's very remarkable. And I think the contact point that you'll notice on each of these slides, Sorrel is in the room. We can talk to those people and touch them with our fingers, shake their hands, give them a high five, like they're here. It's not something that's made up in science fiction. These are amazing robots. They move around, they look at space, they look at stars. They look like the poster of Contact, right? And there's data coming down there that we might want to do stuff with. You could even go work there. They asked you to go and work there. I mean, gosh, there's posts available for us. Like, this is real. The Juno spacecraft. Anyone know about the Juno? I'm going to make your arms work. Juno? Somewhat familiar to the room. Okay, Lily's raising her hand way up high. Lily asked me to show her badge. She got this badge, which is the Juno mission badge, because in terms of contact, this robot, let me just tell you about, this is the largest robot made by humans. It has traveled the fastest of any man-made object and went to Jupiter to go and take pictures, and it will still be there for the next year or so, sadly, and then it's going to be done with this mission. But it's pretty amazing, and what's even more amazing is from a contact point of view, Heidi Becker was a mission lead on the radiation instrument. She was here in Cape Town. She stood in the planetarium. She stood under a projection of her robot that she'd worked on, speaking to a room full of children, and then afterwards signed the autographs of the kids, they had mission pins from her, they could ask her questions, and then showed them the public APIs where you can get that data and do your own citizen science on it. So those are really massive robots, and we've all heard of those robots, right? We come down closer to Earth, right? So we started with Sorrel observing deep space. We've come past Jupiter, now we get to Mars. So Mars has quite famous rovers on it. We may have heard of Perseverance and Curiosity. This little guy here is a whale, apparently. Is a MARS robot, Mars rover. It's a mobile autonomous remote system. It's a copy of that guy, but this is his selfie, and in the background there you can see actual Mars promo imagery from the JPL. Here you can see the European Rover Challenge, where there's a Mars yard where students run rovers in the yard. Here you can see a robot in the REMI, the remote Mars yard in Poland. And this little guy is soon going to be in a classroom here in Cape Town as a remote Mars yard. Matthew is somewhere in the room of the back there. Matthew is a South African Planetary Institute exploring nature with technology, and they're building tiles for this guy so he can move over something that looks like Mars. And we can have competitive challenges to the point of speedruns where young people can actually try to go and take a picture of the rock the fastest. And how am I going to run my code? And it could be a young person like you. It doesn't have to be school age, but the school age people are probably going to have more time and more likelihood to do it. So what I didn't know if I was going to want to do, yes. I have more time.
Oh, yeah. You started late.
Okay.
So, 25 minutes from now.
Oh, good. Okay. So that is thankfully not on Mars, so it's a bit easier to deal with right now. It is connected to my hotspot on my phone, and it uses a local link addressing. I'm going to SSH into Mars at marspy.local. And then with any luck, I'm on the right Wi-Fi. This thing has changed Wi-Fi. No, it's on the right Wi-Fi. Oh, but it's not on. In the world of computer problems, this is probably the most important one to solve, turning it on. So while it turns on, and I'm going to give it some power here. So it's running a Raspberry Pi 01 So it's a relatively slow process. Everyone's like, wow, you can do stuff with one of those. There's a ton you can do with them, right? Lily's home robot that's not here runs on a Raspberry Pi Pico. The Raspberry Pi Pico, the RP2040, is between 50 and 100 times more powerful than the computers that put people on the moon. So if you want to know what you could do with a tiny $4 or 82 Rand controller, you can put people on the moon if you like. And then let's see when Mars comes alive. Oh, it's not alive now. Okay, we might get back to it moving. You probably saw it moving at lunchtime. It takes a while to boot up. I thought it was on. It was not. Let's move back to the main event. So this guy is going to be trolling around. You will be able to connect in. And the key thing is a contact point. There'll be remote yards. You can connect in and then actually really run it on real challenges and see video footage of you moving a real robot, which is kind of the key. Because if I tell you you're controlling a robot and then you see an in-game sprite, you get a bit disappointed. You know, like, oh, we're going to do robots. And then I've moved a little like pixel thing around the screen. It was cool and I used my imagination, but there is something that happens when there's a thing. You give that one more second. Look at that. We've got a ping response from Mars. Much better ping responses than one would expect from Mars, but and so there's just a shell script in here. I'm not going to, I could cat it. Which there's nothing happening in this other than running a Python script. In fact, that Python script is then going to drive this rover and it's going to start a nice interactive shell because that's the kind of thing you need. Get the cat out. Cats and keyboards. I mean, shh, go away. Okay, and then hopefully it's going to connect to the subsystem, which is hopefully all on. There we go. Okay, so now nothing more exciting than pushing forwards is going to make the little guy go forwards. And there's kind of a cool moment. Lily actually made this whole robot out of a kit because, as I said, we can use our kids. I was low on time and I was like, hey, do you want to build a robot? This would be really great. And she did most of the build except for getting the camera mast on. So this thing, we've been doing incline tests, which is why I thought to put it up like this. It has taken a small fall or two, so if I'm looking a bit more anxious, it's just making sure how it goes. And it has a rocker bogie on it, but I thought using the incline, you could probably see it from the back of the room. It has, now I'm going to just put him up here for a second. So it has these rocker bogies on it, just like the real one on Mars, and they do this thing where they can like click over terrain and move over. And oh, there we go. There's a nice little thingy there. And so if he sits there, he can still drive, or she, I don't know, we haven't decided. It can sit there and then get drive on all the wheels as it moves over stuff. And it looks really cool as it does that. So, you know, it's going to, there we go. Oh, look at Lily. She's worried. Okay. And then it's actually running a full like computer there. So if I connect to Mars Pi on VNC, I get my remote desktop experience, and then I can pop open a shell, which takes a long time. And I've got a shell script just to make my life easier, to start the camera. And there's a little camera on the front here. And so that's a full little science deal there, right? As that camera is going to start up, it does take its time. So I'll do some filler talk and we'll go back and have a look at it in a second. Here we go. So this is running on on a ribbon cable that's quite dodgy. I will show you that later. Okay, and that's the other thing with robotics is they're fiddly. So you want someone like me who's quite comfortable unplugging and plugging in a ribbon cable to be there and not have some teacher or some child there, which is why a remote Mars yard is a fantastic thing to have. And yeah, if anyone wants to get behind that or get part of that, that's happening. So now we're at Mars and Earth simulating Mars and understanding how all that works. And the kids who've taken part in all of this were really fascinated to hear how slow the real Mars rover works. When we had a talk that Matthew had organized for us when the kids were going to get their certificates for running code in space, they then found out that the rover goes so slowly because actually we're scared it's going to bump into stuff just like this one. So we take a step and then we check, are we okay? We take another step, and the cost of failure is so high, it doesn't drive as autonomously as you might think. And those certificates that the kids got were for the AstroPi challenge. So this computer here is a Raspberry Pi 4B, but it's got a sense hat on the top. And Lily is going to, she's controlling it using a fun little Bluetooth application that I wrote using something called Blue Dot, which lets you control the Bluetooth on the Raspberry Pi without knowing anything about Bluetooth, which is so important because Bluetooth is hard. And it allows you to add a set of dots. Lils can give that phone to someone in the audience, because kind of the goal of me doing this is to make it possible for people who have maybe not played with high technologies before to get a feeling for what it feels like to be like, I can control this thing. And then it's not such a big leap to think, well, if I wrote that code to control that thing and showed that picture, that's the same way the picture is going to show on the space station. Because there are two of these computers on the International Space Station. And these two computers, I'm sorry to tell everybody in this room, were put there with one purpose, and that's for young people to run their code in space. So if you're over 19, can't play. But you can help the young people do it. And this picture here is actually the window of the space station. The window of the space station has two of these in, so that is one of those, and another one of those. And there's two missions, two challenges. So remember I talked about the challenge of robotics? Challenge is a good thing too. Soccer is a good challenge, rugby is a good challenge. There's a robot challenge where the European Space Agency lets young people run their code in a simulator on their computer, show a pattern on the screen, see what it will show, use one of the sensors. This year it was the color sensor. Then they had to change the background image of those LEDs. And then if they could do all of that within 30 seconds without bugs, submit it to the space agency. The space agency then tests that, put it on, they SSH it up to the space station. The astronaut takes the code, puts it onto one of those computers. Your code runs in space for 30 seconds. And then you get a certificate to say your code ran in space, signed by the astronaut and the head of the space agency and the Raspberry Pi Foundation, that you get to have at your school and completely blow everybody's minds, right? And it runs on a computer not unlike this one. So it's very imaginable, and you can touch with your fingers. The camera that looks outside of the window looks like this. And Lily was part of the first team from South Africa to take part in the Mission Space Lab, which is the more advanced project. So we've done 4 years in a row of Cape Town and South Africa taking part in this mission. This year, we did the bigger project. This year, they needed to take a reading of the speed of the space station somehow. Lils, do you want to explain what you did? I haven't actually prepped you for that, so I could drop you. You can try to talk into this guy and just say what your code did.
What we did was we took pictures of Earth from the International Space Station, and we were running code to calculate the speed of the ISS, and then we got data back which told us it showed us our pictures and told us how fast the ISS was moving according to what we calculated.
Cool. And that code used one boring line of code that was Open Computer Vision that extracted the features, another line of code that zipped the features together to figure out like what your interpixel difference was. The hard part was the trigonometry to work out the height of the space station, how big each of those pixels was. But luckily there's an online calculator for that. And then average it out. I spent my time just checking and debugging and running it for them, and just because like, we're going to send this to space. And then it ran in space. It took 42 pictures. Did you want to say something? Do you want to fetch the phone? And then one of those photos I printed out for the kids who'd run their code in space, and they've got a little photograph, and Lily gave one of those to Heidi Becker and asked her to autograph it for her. So she's got a signed message from a NASA JPL person because of the power of community, of a photo that was taken on the space station by a child from Cape Town. She was 10 at the time. It was a 10-year-old, an 11-year-old, and a 13-year-old, 3 very different schools. And you may guess my daughter goes to a private school. The other boy went to a government school at Queen's Park. and the other was at St. George's, I think. So, and then their partners in Europe were in the Czech Republic. So, sure, amazing. We had to meet people in other countries. I can speak about AstroPi forever. But coming a bit closer to Earth, there's another remarkable robot, and that's just here in Stellenbosch. Does anybody know about Cloudline? Mind-blowing company building an 18-meter like steampunk airship, helium, all that stuff, with the goal of picking up stuff and dropping it off. And they're so kind and interesting that they've said, I can take this very computer and strap it to the side of that thing on a test flight. And the first science mission is going to be exactly the same code that ran on the space station. But then after that, they're open for schools, kids to run it, say, well, how does the pressure change? Because it's got a pressure sensor. How does the temperature change? Because it's got a temperature sensor. What does the color look like? If we took pictures, could we count the trees and cows? It's going to just be a little friendly hitchhiker on there. You'd run it in a simulator because there's a full sim for this thing. Once you're ready, you go fly and then do science in the atmosphere. It's amazing, and that's what robots really make us able to do. And then, like, going lower than the atmosphere, we get underwater. Now, this is a super exciting moment because we've got the funding approved for this LOCO AUV. Low cost, I put it in quotes, underwater vehicle. Low cost from like a underwater vehicle perspective is still $4,000. But we got the parts budget together with Ocean Hub Africa. They're based at the aquarium. They're going to be hackathons soon. So if you're interested in robots, like Watch This Space, there's a WhatsApp group. There's a document you'll see at the end to join the group. And we're going to have some hackathons to make it. The engineer in residence at the Ocean Hub has done the 3D modeling of this again. But it is an open source robot. The Gazebo Sim is open source. You can run your simulator on any computer without paying for software. Once it works in simulator, just like the space station, you can send your code to the Ocean Hub. They will check it works in their simulator, and then we'll run your code underwater. In the tanks of the aquarium, or if you're doing better in the kelp forests, or, if we want to go exploring a submarine wreck, like a shipwreck or something, that's all on the horizon. And it's a phenomenally remarkable robot. But everybody can't have one because they're so expensive. So we have one, and then we simulate it and make it available to everybody. So children in Limpopo, who maybe have never seen the sea, could run this and get a WhatsApp video back of the fish in the aquarium swimming past their robot as it goes down to take a picture of SpongeBob at the bottom. And that's just like, this is all real. I'm not making stuff up. It's not like science fiction anymore, and it's hard to believe. And when we talk about challenges, there's a challenge. Someone asked me the other day what I think about FIRST. Someone from Thinks, who actually sponsored this team, Team TechSpan, who went on to win the World Cup in robotics. And they're based in Pinelands in a garage. So can we do it here? Yes, we can. What you're looking at there in this picture is the Samsung Future Innovation Lab at the University of the Western Cape. 3 local teams who play in the FIRST Tech Challenge got together to show off their robots. You can see the 3 wheels here of the Mars rover. You can see the First Lego League mat. Community, 2 different challenges sitting side by side, all showing off robots at the rover event that we had, that we actually got this guy for. And those rocks there are actually Matthews rocks. They're not just any rocks. Those are all parts of like ejected matter from impact craters. And everyone has a story. Oh, this guy's 3.5 billion years old, and this happened in these 30 seconds. And he was telling kids these stories. We were getting excited about exploring nature with technology at this event. And the FIRST Tech Challenge happens, but it's quite hard to get into. So at that event, we had this idea of getting all the different robots out to show and play with. So you can see here, playtime on the mat, different robots. Some of them are like the Microsoft Research robots from South Africa. Some of them are NVIDIA JetBots. One of them is Lily's Pico Go. One of them is this little cute bot that we see here. One is actually running autonomously at the time. But it was just a chance for them to play together. And that little 15, 16-second segment hopefully is sowed a seed. I need to keep moving. No, there. Okay, so I promised to code along. And if we're starting to fall asleep because of the extra information, now's the time. Devices, laptops, pull them out, ruffle about, get a moment. We're going to have a look at MakeCode. Has anybody used MakeCode before? 1, 2, 3, 4. Okay, so MakeCode I'm going to get into in a little bit more detail just now, but it's kind of clawed on there. Yeah, it stays. Great. No, I'll do it on here. It's fine. You can if you want to. So I put a little snake on there for this slide. On the right-hand side is Blockly, which is developed by Google. It's sitting inside of a tab, which is Microsoft at the top. If you click across to the Python tab at the top there, you'll see Monaco, which is a Microsoft technology. And on the left-hand side, you see the microbit, which involves like 30 different collaborators, as all in the interest of open source and kids' education, all playing nicely together. So go to makecode.microbit.org, or just Google for makecode, to be honest, or Google for microbit, and you'll find that site. Get yourself there. The GitHub repository down below is just for those really keen souls who want to contribute. But can I get a sound of joy if you've got it open already? Woo, woo. Yeah, I heard a thumb. It's a very loud thumb from the back. Thank you. Cool. We got a couple of people with it open. Is anyone got to open that back corner? Because if one person has it open, everyone can have a look. Is that, yep. Okay, so now you have peers who can peer over your shoulder and see what's happening. So it runs on a phone. It runs a bit more easily on a PC. And how do you get started? Well, you're going to probably start playing already, which is the right thing to do. And yes, and then show other people what you're doing. What I'm going to do while you do that is try to figure out that swipe. I'm new to this whole Mac business. Okay, claws. Okay, go that way. No, that way. Okay, let's go you. There we go. Okay, so here's one I prepared earlier, just in the interest of time. So what's different about this is not what I wanted, so you can go away and you can go away. Just in case you're not following along or doing it, so on startup, so this sets a radio group, because I thought I'd show you something a bit different here. And so then when this code runs, something else is happening there. Let me just give that a reload. We've got a microbit that when I push the A button is going to show this heart. So under here, I could choose the different LEDs. And here I have a microbit. So that's how big they are. And when you plug them in, they blink their light as they synchronize. And you can see this one is actually showing a heart because it's preloaded with that code. Yay! Okay. And I press that there. Okay, so that's happening. And then I can click the download button and I send my code that I'm running on here onto this microbit. I'm not going to load it on the other microbit. Yes, I am. Lily, can I have the other microbit? It's like one of those live coding questions where you wonder whether you should really do this. So if you've been playing along, you've probably, so this is the project pathway site of the Raspberry Pi Foundation, where we have nice guided pathways into things like Scratch or web design, Unity, Python, and microbit. I like going to the microbit also because it's a lovely thing. It's hard to break. Also, it shows how technology agnostic the Raspberry Pi Foundation is. And on the first project, we're going to look at making a music player. And when we get into making a music player, we're going to do a little project that when we do something, it's going to play a tune. So the reason I'm doing this is I'm just hopping in here to show you how the step-by-step instructions really take us through. So it's not intimidating at all. There's a play melody block. If you drag that in, you'll probably start to hear sounds. And then there's this show icon heart block. So my code is showing a heart. And let me go back, oh man, to there. Switching from Windows to this operating system is hard. Okay, and then because that wanted a melody, I'm going to ask for that melody. So I'm going to scroll down and find the melody da-da-dum. After the heart, we're going to play da-da-dum, and then we're going to send something on the radio. Have you got the other microbit? Yes, you do.
Yes, I do.
Okay, I'm going to download again. I will read down the other code to that. Okay, so these little guys are really fun for playing with. They've got an edge connector with 25 pins, 5 big ones that you can stick a little, I think a 4mm bolt through, I found out the other day, or you can put crocodile clips on, you can connect LEDs to them. and you can control the LEDs on them. But I think the most important thing that you wanted to see was first, when I press the A button, I see a heart and I hear that little rhythm. I mean, that's the code there. You see it. And the fun part is I can click over here and see the Python code for it. And a basic show icon names heart, music play default and background. And I can go back here to the blocks. And if I change it from da-da-da-dum to the entertainer, and I go back to the Python, I can see how that works. So conceptually, I can see how that works. This is Monaco, which is the same editor that's used in Visual Studio Code. So if you're anti-Visual Studio Code, you can just throw sticks at me. But it's actually quite a nice code editor. I didn't make it, but I do like the fact that it just works and it's embedded there very nicely. And then I'm going to download this onto this other microbit now, because microbits have a couple of cool tricks up their sleeve. One of them is the push button that I just pushed to get the light. They've got a buzzer. They've got radios on board. This one is now pairing. And a download. Hopefully it's also paired. Yes. So there is a moment where you need to get your web USB thing actually pairing properly and get it down. Mostly that involves something popping up and working. And if it doesn't work, then there's the option of downloading a file, and it appears as an external drive that you can drop files onto as easy as that. You drop the hex file on and then you've loaded the code. So now we have another microbit running the same code. So what we've done is we've loaded the same code on both microbits. One of them, or both of them, are able to send a message actually. I haven't actually tested this before because I'm crazy like that. But so Lily, well, I'll ask her to hold this one here. If it's powered up, yeah, it's powered up. So if the code is right, which is a high probability it isn't, and I press this A button here, what do we expect the code to do? As Sheena said, we need to think, what do we expect the code to do? I should see a heart. This should play the entertainer in the background, which means it'll immediately go and send radio number 0. When this receives anything on the radio, it's going to show a snake for Python. If you don't think that looks like a snake, I can prove you wrong, because actually you'll see it has icon names .snake. It is a snake. And I didn't set that constant, so it must be correct. So I'm going to push this button here. And is that powered up? Did it get anything? No snake. Okay, let's push this one here. See, we got a heart. Radio received. Did it start up? Push your A button. Did you get a heart? Oh, I got the snake. So technology is a bit like that. I'm sure I'll get the snake back now if I push it now. Yeah, look, there's the snake. I sent the snake. Yay! I mean, there's a kind of magic there. And all of you have done some sort of code there. If you want to run it on these microbits, come afterwards, run it on. It's so fun to see whatever you drew actually appearing in the LEDs. And when I push a button, something happens. And that's that kind of little loop of joy. But you're probably feeling a little bit betrayed right now, because this is not a robot. Dave, that is not a robot. It did some great stuff, but it's not a robot yet. But the cool thing with stuff like the microbit, and the one thing that I really wanted to touch on today, is that I like sim to real. We've simulated this and we saw it happen really. There is an extension called microbit robot, which you have, if you have the microbit open, you need to actually search for robot in the extensions. I'll show you what it looks like. You click on extensions at the bottom, and then you type in search and you type in robot. It won't come up in the list because it's in beta, but it's there. The most mind-bogglingly fun thing about this robot extension, and I'm just going to take out this radio group yeah, that should be fine, is that it has been made to have the same code for all of these robots. So you can learn the same blocks, have the same project, and if you have the AcuteBot Pro, which is down there, you choose the Electfreaks AcuteBot Pro if you can click on the right place. And then when you start your code, you get a simulator with that robot in. That, first thing you want to do is say, can I move it around? Yes, you can. Up. Yay, I got a robot. But I didn't get a robot to drive it by hand. I got a robot so that I could run code on it. And so I'm going to say when I push button A, which is this code over here. Oh, this is messy code. Let's zoom out a bit. No, okay. Go away. Clean it up. This Lily's told me I can clean it up. Okay. Bye. right click, format code. Woo! Linting. And now what I'm going to do is after we start, when I press the A button, I'm going to go down into this new section that added because I chose that extension for robots. And now I can tank the motor. Are we doing a time? Yeah. Okay, cool. That's amazing. So I'm going to wrap up in seconds. Can I take like 2 minutes to wrap up? Yeah. Okay, cool. So you really want to see this happening here, which is that going to 50% or 80%. So now the one motor is going to get less power than the other motors. And then I'm going to come up here and I'm going to press A. And the robot's going to drive in a circle. Oh, yay, crash, boom, bang. And that's really what we want robots to do. If I ran that code on that little robot, you would see it happening. I'm not going to. During the Q&A, I will load the code. I'll load the code now, and during the Q&A, you can watch it drive around over Bluetooth with code that looks like this. I'm just going to touch on the code for a microsecond. There are Android apps that can connect over Bluetooth to this thing and send it events that you'll receive, which have button presses and stuff. So you can have like a little D-pad that controls it and makes it move around. It does stuff remotely. And then when you plug this into this, it is then the brain of a robot, and you have a robot. And this is like under 1,000 Rand of robot hardware. So it's relatively accessible, but still expensive. But if someone were to send you the code, you could run it for them and send them that WhatsApp video. So there we are. Now I am going to show you the sim. We'll see the real during the questions in the interest of time. The code that we're going to be running on there was written by these two girls. They're both 9. It's not Lily, it's her little sister. This is Lily's little sister's actual robot that she got actually for her birthday, that she's lent us for today as long as you take good care of it. So my last call to action is to contribute. Does anybody know what that picture is? Yes, Matthew. It's the machine from Contact, right? So I talked about Contact a bit earlier. This is the Carl Sagan introduced this idea of Makindo, the global collaboration to build the machine. Right? It's going to take us all. This like, let's get together and build a machine that's so complicated. These machines need us to work together. This is the collaboration for that little code along you saw. ARM, BBC, the British Council, Microsoft, Nominet, Nordic, Google, Raspberry Pi Foundation, Elect Freaks, and the Institute of Engineering, and UNICEF, and a whole bunch more institutions all contributed to make that little demo that you've just done possible, which is somewhat mind-blowing and would be completely impossible if it wasn't for the ethos of FOSS. What can you do? We need help to smash rocks. There's tons of repos that could do with more maintenance. The one I'm working on at the moment is PXT Maker. Smash the rocks so that we can turn the big, hard to get over stuff into stuff that just little kids and turtles and things could get into. Hackathons to make things together. Look out for them locally. We'll be having one for Loco. There'll be stuff coming up for Scratch pathway translation. All this FOSS works on your machine, so play with it. And that's probably the coolest thing you can do. It is free. It is available. It's free as in freedom. You can change it. And that's what I'd love to see us all doing today. I took us through what's happening in South Africa, how we can design environments, what robots we could play with. We all made something in Make Code, and I've invited you to contribute. My topic is a hat tip to Nelson Mandela, who said, let there be justice for all, let there be peace for all, let there be work, bread, water, and salt for all. Let each know that for each, the body, the mind, and the soul have been freed to fulfill themselves. So let there also be robotics for all. And thanks for listening.
So we are now very much in tea time. So this is a great talk. I loved it. I'm sure many of you did as well. So if you want to stick around and ask some questions, then please do. But I'm just going to give you a moment in case you do want to leave at this point as well. Yes.